All right, Math 1513, College Algebra, Northern Oklahoma College. I'm on chapter 1.2. This is an example to help you with your problem number 37. It's kind of like problem number 38, sort of. So it's the first plane leaves at 400 miles an hour. Second plane leaves and it's going faster, 600 miles an hour, but it leaves 2 hours after the first plane left. How long will it take the second plane to catch the first one? Well, we have to come up with some kind of equation. So if you think about it, what you're asking is, when will they have covered the same distance? So we could ask ourselves, we could be thinking, when will the distance be the same? Because that's when the one plane catches the other. They left from the same spot, so whenever they're together further down the line, that's where they have both covered the same distance and they're both basically right beside each other in the air. So something I could be asking myself is, when is the distance covered by the first plane, I'm going to call that d sub 1, when is the distance covered by the first plane equal to the distance covered by the second plane? So if we can figure out how much distance the first plane covers and how much distance the second plane covers and set them equal to each other and solve, we'll know when the second plane will catch the first plane. All right, so I'm just going to write that up there in the corner. When is D1 equal to D2? When is the distance of the first one equal to the distance of the second one? Well, let's think about the distance covered by the first plane. Well, how would I calculate that distance? Well, the first plane is going 400 miles an hour. So I can say the distance covered by the first plane, is 400 miles an hour. Now, what's the rest of it? Well, I have to know how many hours it's been in the air. Because if it's been in the air 1 hour, then it covered 400 miles. If it's been in the air 2 hours, it covered 800 miles, and so on. So what I need to know is how long it's been in the air. So distance covered by plane 1 is 400 miles an hour times the number of hours it's in the air. We can shorten that, we can abbreviate it and say distance, whoops, let's go to the black ink. Distance covered by plane 1 is, almost always means equals, 400 miles per hour, I'll leave the MPH off, times, now what are we going to call the number of hours that it spent in the air? Well, I'm thinking number of hours, that's time. So we're talking about a measure of time. So I could say 400t, but if I think ahead in the problem, I know that the plane number 2 is going to be in the air a certain amount of time as well, but it's going to be in the air a different amount of time. So I'm going to have 2 times. I need to label this as the first time, or the time of plane 1, to keep my times separate. So to simplify it even further, the distance covered by plane 1 equals 400 times the number of hours that plane 1 has been in the air. Now in the same way, we can say the distance covered by plane 2, I'm going to call it d sub 2, the distance covered by plane 2 is 600 miles an hour times the number of hours that it's been in the air. Now, it's been in the air a different amount of time, so I need to label that as a different t. So I'm going to label that t2, or t sub 2. So that's the number, t sub 2 is the number of hours that plane 2 has been in the air. T sub 1 is the number of hours plane 1's been in the air. So here's where we stand. We have an expression for the distance covered by plane 1, and we have an expression for the distance covered by plane 2. And the question we're asking ourselves is, when is the distance covered by plane 1 the same as the distance covered by plane 2? Because that's where plane 2 catches plane 1. All right, so I can take out D1 and replace it with something that means the same thing, the 400. That's distracting. The 400 T1, and I can take out the D2 and replace it with an expression that means the same, 600 T2, and we're getting closer. Okay, what's the one problem we have now? Actually, it's 2 problems. We have 2 variables. Remember, we can't solve an equation with 2 variables yet. We'll learn that later. So we have to rewrite everything as T1s or rewrite everything as T2s. It doesn't matter which way we go, but we have to rewrite the equation so that there's just one variable in it. So I have to figure out how to relate T1 and T2. So I go back to the problem, I look for more information, and I remember that plane 1 has been flying for 2 hours longer than plane 2. That means that the time that plane 1 has been in the air is 2 hours longer than the time plane 2 has been in the air. So the time that plane 1 has been in the air is 2 hours longer than the time that plane 2 has been in the air. Well, now that I know that T1 is the same thing as T2 plus 2, I can go back to this equation right here, and I can take out the T1 and replace it with that, since it means the same thing. So replacing that T1 with T2 plus 2, now I have 400 times T2 plus 2 equals 600 T2. And now we have an equation that we can solve because we have the same variable all the way throughout the equation, so that makes it easy to solve. So I distribute the 400, I multiply both numbers inside the parentheses times 400, and I get 400 T2 plus 800 equals 600 T2, and you guys see where this is going now. I have T2s on both sides of the equation. Which one do I get rid of? I usually get rid of the lower one, it's less work. So I minus 400 T2 from both sides. I have 800 equals 200 T2. Divide both sides by 200. T2 equals 4. You think you're done, but you're not. Okay, even though you've come up with 4 equals T2, since this is a word problem, you need to explain in words what your answer means. So what does this mean, that T2 equals 4? It means T2 stands for 4 hours, and T2 stands for plane 2. That is the amount of time in the air that plane 2 spent before it caught plane 1. So say that in words. Plane 2 will spend 4 hours in the air before it catches plane 1. Okay, here's another nasty, evil mixture word problem. This will show you how to do 49 and 51 on your homework. We have 10 pounds of tea. It's $5.80 a pound. How did they make it? How did they blend that? They took some expensive tea at $7.50 a pound, and they kind of weakened it, all right? They mixed it with some $3.25 a pound tea. So they blended those two teas together and came up with a blend that they're selling for $5.80 a pound. So how can I turn this into an equation? Well, let's look at it piece by piece. 10 pounds of $5.80 per pound tea. So 10, and remember of almost always means times 5.8 for $5.80. Next we have is blended from. Remember the word is almost always means equals. How many pounds of 325 pound tea? Well, how many pounds of 325 and how many pounds of 750? Are they going to be the exact same number of pounds? No, they're not. It's going to be some kind of mixture. We're going to have a different amount of cheap tea and a different amount of expensive tea. So what I'm going to do is I'm going to use P for the number of pounds of cheap tea, of 325 tea. So P is the number of pounds of 325 tea. Now, since it's going to be different from the number of pounds of expensive tea, I'm going to call it P sub 1, P1 for the cheap tea. If you want to, you could write P cheap for the cheap tea, or you could write P 325 to remind yourself that that's a 325 tea. You can do it any way you want to. I'm going to call it P sub 1. All right, plus how many pounds? Now remember that's a different weight. So P sub 2 of almost always means times 750 tea. I'm going to call it 7.5. So I clean it up a little further. 10 times 5.8 is 58. And I just reverse the order here because you can multiply in any order. So 3.25 P1, 7.5 P2. It's a little bit simpler. All right, notice we're back to the same problem we always come up against in these word problems. We have two variables. We have a p sub 1 and a p sub 2. We don't know how to solve equations with two variables yet. So somehow we need to relate p1 to p2. And we have to go back to the problem for more information. So I go back to the problem and I realize that we're dealing with 10 pounds of tea altogether. That means the pounds of T1, the cheap tea, plus however many pounds of expensive tea has to add up to 10 pounds. And now we have an equation that relates P1 and P2. And you can isolate either one. Doesn't matter if you get the P1 alone or the P2. I chose to get the P1. So I subtracted P2 from both sides, and I end up with P sub 1 equals 10 minus P sub 2, or the price of the cheap tea is 10 pounds, or I'm sorry, the pounds of cheap tea is 10 pounds, take away however many pounds of expensive tea we use. Okay, so let's go back to where we got stuck. We got stuck right there because we had two variables. So since we know that P sub 1 is the same thing as 10 minus P sub 2, I'm going to take out that P sub 1 and I'm going to put in 10 minus P sub 2. And now it looks like this. 58 equals 3.25. I took out the P sub 1, put in 10 minus P sub 2, plus 7.5 P sub 2, and the rest is just algebra. I distribute the 3.25 and get 32.5 minus 3.25 P sub 2. I have another P sub 2 here I can add like terms. And I get 58 equals 32.5 plus 4.25 P2. I'm going to go ahead and finish solving for P2. We subtract 32.5 from both sides and get 25.2 equals 4.25 P2. Divide both sides by 4.25 and get 6 equals P sub 2. Now, remember, you're not done. Explain to me what you found out. What does P2 mean? What does P2 equals 6 mean? Well, it means you have 6 pounds of the expensive tea. Okay? Always explain to me what it means. And what about P sub 1? What about the number of pounds of cheap tea? Well, you can go back here to that equation we had earlier that related P1 and P2. Remember, they have to add up to 10 pounds. You know that P2 is 6 pounds. So we just solve for P1. And P1 has to be 4 pounds. Now, since it's a word problem, you need to explain your answer in words. Okay, so here's a perfect answer, I guess, or near perfect. To make 10 pounds of tea that runs $5.80 a pound, you would blend 6 pounds of $7.50 a pound tea, the expensive stuff, with 4 pounds of the cheap stuff, the $3.25 a pound tea. And now you guys know how to blend tea. Congratulations.